recording. Great. So once again, good afternoon, everyone, and I apologize for this delay due to the technical problem. This delay happened, but we are going to very fast here and try to cover all the topics. So guys, today we are going to learn solid principles in C#, and this webinar is brought to you by Infragistics, and I'm sure that all of you are aware about our esteemed organization Infragistics. We have a tool set along with the development stack which you can use to create a better user experience and deliver the project at a faster rate. We have controls for Android set, Windows 8, ASP.NET, MVC, jQuery, and etc. So I would recommend you that if you want, you can go to infragistics.com and look into our products and tools which we provide you, and if you have any question, you can get back to us. So to start with this, and let us now quickly jump to solid principle, which is agenda of today. Great. So today, my name is Dhananjay Kumar. I'm host for today webinar. I'm 6 times Microsoft MVP. I am a Infragistic consultant. I'm 7 times csharpcorner.com MVP. You can find me on Twitter, which is debug_mode, and I blog on debugmode.net and as well as on Infragistics blog. Great. So agenda for today webinar is very simple. 5 topics. We are going very fast in that. Okay. Great. So we'll start with single responsibility principle, open close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. These 5 are these 5 are a full form of the solid. So S stands for single responsibility principle, O stands for open close principle, L stands for Liskov substitution principle, I for interface segregation principle, and D for dependency inversion principle. We are going to look into all these 5 one by one. So let us start with single responsibility principle. Here in a glance, we'll see this slide later, but in a glance you can see that a single responsibility principle says that a class should have only single responsibility. So let us go here. What we call SRP. SRP says that a class should have only one responsibility. I repeat, SRP says a class should have only one responsibility, and a class should have only one reason to change. So if your class have 2 responsibilities, it means your class got 2 reasons to change. If your class has only one responsibility, it means your class got only one reason to change. And SRP says, single responsibility principle also says that either a class must be used in its entirely or it not at all used. Okay, so this is single responsibility principle. It's very simple. So if you have a class, and that has 2 functions, one to calculate salary, another to print the salary slip, it means that class has 2 responsibilities, and you may want to refactor that class is violating SRP principle. So here I read it out that there are more than one functions reason to change in a class. Even if we change one of the function, we will have to retest the whole class. So try to understand that we have 2 functions in our class, one to print salary, another to calculate salary. Now, since there are 2 functions, it means there are 2 responsibilities, and if for any reason we are changing one of the function, for better software design, we will have to retest the whole functions, which we don't want, right? If we are changing one function, we should only test one function, not the whole function. But if we have created a class which is not following SRP, we have to retest all the functions which is not modified, right? You can say that responsibilities could be you are persisting data, you are validating, notification, error handling, logging, parsing, mapping, sending mail, printing, etc. So if you do these tasks in your class, they can be one responsibility, right? Uh, Another classical example of SRP violation is you must have seen a class which is performing some task and at the same time logging the operation as well. So you have two tasks being done by the class. One, let us say to calculate salary, and another to logging the functionality. So here you are violating the SRP. So to summarize, SRP means a class should have only one responsibility and a class should have only one reason to change. So let us quickly jump to the SRP demo and see how it goes. What I have done, guys, that I have created a console application over here. Okay, and in this console application, it's normal console application. Okay, and so here you see that let us say we quickly go and create a class. I'll go here and add a class called, add a new class. Let us call that a class as uh, SP class. Okay, sorry, SRP class dot cs. And now we have this class. I mean, I've just added this class. Probably we don't need that. Now let us go ahead and add a class called public class salary. Okay, so I'm going to give you a very simplest example of single responsibility pattern. Okay, when we go to because this is easy to understand, when we go to another principles like Liskov substitution and open close principle, we'll go into much more complex scenarios. So here I have a class called a salary, and in that class, let us say I have a property called a per day rate. So this is a normal class, which is the property called per day rate. Then I have another property called, let us say, number of days, which is here. So I have two properties in this class, and then I have a function. What that function is doing here, this is a very simple function, calculate salary. What it is doing is that it is returning salary for by multiplying per day rate and number of days. Now I have one more function in this class, for example, and that function is print salary. And what that function does, it simply print the salary. Right now I am let us say right now let us say I am printing the salary uh, in a give me a minute. Right now let us say I'm printing the salary in a console, and I'm printing that like this. Okay, this is a very simple class in front of you. You see that this class has two responsibility, one to calculate salary, another to print salary. So we can say that this class is violating the SRP. Because tomorrow, if we need to change the print salary for some reason, right now we are printing that in console, tomorrow we want to print that to a printer, what we will have to do, for if we are following all the designs, we will have to test calculate salary as well, even though we are only changing the print salary. So the class which is in front of you right now, this salary class, is actually violating the SRP problem, because this got two responsibilities, one to calculate the salary, another to print the salary, and since there are two responsibilities, it got two reasons to change. Okay, so here how we can refactor this. Okay, this salary class, because this is validating this. What we can do, probably we can break this class into two classes. We can say public class, and instead of salary we can call this class as calculate salary. It will have per day rate, number of days, then we'll have calculate salary, then we'll say this dot per day rate and per number of days. That is great. And then we'll create another class, for example, and the another class will be public class, let us say print salary. Okay, and this class has only one responsibility, to print the salary. In this we will pass the salary which is to be printed, so we can say double salary. Okay, and then we can say that console dot write line salary. Now you can see that we have two classes here. Okay, one to print the salary, another to calculate the salary. Now this class calculate salary has only one responsibility, to calculate the salary, whereas print salary has only one responsibility, to print the salary. So tomorrow, if we are changing the logic to print the salary, only one class will be impacted. So essentially, or roughly, you can say that one class should have only one method or only one responsibility and only one region to change. So this is how your you can refactor a class in which will adhere to single responsibility principle. Great, and of course we can go ahead here and then use this class in the main method. We can go here and say calculate salary here, and then we can say s dot calculate salary, and then print salary. We are creating object of print salary, and then console dot read key true. Okay, and when I'll go and run this, some error. So probably this is one class and then this is another class, and we don't need this. Right now, if we go and run this, okay, so right now if we go here and then run this, we should able to run the program and should able to see the output over here. So you see that we are getting the output. So this was the simplest example we can think of single responsibility principle. And the idea is very simple. One class should have only one region to change, and ideally should have only one method, if I can call that roughly, and only one responsibility. Great. So this is your single responsibility principle. Let us go deeper, and next we are going to learn about open close principle. I told you that I will take very simple example for SRP. However, for open close principle and other principles, I am going deeper. Great. So let us go here. We have completed SRP, and let me see some questions. If have something on SRP, should have only one method. I'll answer your questions in the last. Great. Now, what is OCP? This is second component of your solid principle. OCP stands for open closed principle. And what OCP says, a class should be designed in such a way that it should be open for extension, however closed for modification. So what it says, that you should able to extend a particular class, but you should not modify that class. This is what open closed principle says. So consider a scenario. I'm going to give you a real-time scenario. Let us say there is a class with the responsibility to calculate discount. Okay, so you have a class which is going to calculate the discount. Okay, I will request you that hold your question as of now and focus on the presentation. And in the last, you'll get a chance to ask your questions. So if you keep thinking about the previous principle, you may miss what we are learning currently, right? Uh, so hold your question, note it down on the paper, and be with the presentation. And in the last, we'll talk and try to answer your questions along with my colleagues. Great. So here you see that let us try to understand what is the problem, how OCP is helpful. So consider a scenario that there is a class with the responsibility to calculate discount, and at the time of a class designing, you have three rules to discount offer. Okay, discounts are calculated on various rules, and that can be implemented as shown below. So let us say if you are saying that if rule 1, then give discount 1, if rule 2, then give discount 2, if rule 3, then give discount 3, and so on. So for example, if you are a shop owner, you are saying that if it is summer, give 10% discount. If it is winter, give 20% discount. If it is Christmas, give 30% discount, kind of scenario you have, and you need to implement that. Now the challenge here is that you anytime in the system new rule can be introduced, right? Right now you may have only three rules, uh, right? And you can write them using if else if conditions, but probably in future in the business more rules will come, right? So if a new rule is coming in the system, you'll go and add new else if in the above code. Agree? Guys, I see many people are saying that you are not able to hear me. Could you just confirm me using Q&A panel that my voice is audible to you? Could you please confirm me? Oh, great. So if new rule is coming in the system, you will go and add new else if in the above code, right? By adding new else if, you will modify the existing class. So try to understand it, guys, in open close principle. If you are calculating the discount inside if else statement, if a new rule is coming to the system, what it is going to do, that it is going to, you are going to modify the existing class. And once when you modify the existing class, you are violating the OCP, you are violating open close principle. You should not modify the existing class, because if even if you do a single modification, ideally you have to retest the whole class, which you may not want, right? So once modified, you have to again test all the rules for the better design. So let us try to understand how OCP works. I request you that focus on the code and you will understand how OCP works. Okay, we'll take the same discount scenario over here. Okay, so I'm going here, and what I'm going to do, I'm going to add a new class. Okay, and let me call that class as discount calculator.cs. Okay, great. I'm going to make this class as a public class. So what I'm going to do in this discount calculator class, uh, I have this scenario. Okay, I'll make this class as a public class, and you see that in the discount calculator class I have a property called discount value, then I have a function called calculate discount. Okay, this function does that, it takes two parameter, amount and rule. And here we are saying that if rule equals summer, give 15% discount. If rule is equal to winter, give 10% discount. And if rule is equal to Christmas, give 30% discount. And we are setting that value to discount value. And then this function is returning the discount value. Okay, guys. So this is how your discount calculator class is created. Now let us go ahead and write some unit tests to test this class. Okay, so we are not going to write code in main method. We are going to write unit tests to test the functionalities, that whether summer, winter, Christmas are returning the expected discount or not. For that, what I'm going to do, I will add one more class, and let me call that class as discount calculator should return. So let me call that class as discount calculator should return. I'm going to write a unit test. To write a unit test, what you need to do, you have two options. Either you can right click on your project, you can say, hey, add a new project, and then you can go to test, you can add a unit test project, and then you can add reference of this particular library and can work with. Other thing is that you can add directly reference of Microsoft.visualstudio.quality tools and add a test in the existing project. And I'm following the second approach. What I'm going to do, discount calculator should return. Okay, so here I have public class discount calculator. I'll go ahead here and then I will write the namespace. And can anyone tell me what is the namespace for unit test? Namespace for unit test is Microsoft.visualstudio.testtools.unit-test. Great. I'm going to make this class as test class because this is going to hold my unit test. So I'll call it as test class. Great. Once this test class is done, created, we are going to create a instance of your discount calculator. Okay, so here it is discount calculator, and I'll call this class as private discount calculator. So this is here a property. Then we will write test setup. So this is test initialized. Test initialized means this particular function will be called each time your test is getting initialized. And inside the test setup, what I'm doing, I'm creating instance of discount calculator. Great. Now I need to write a test to check that whether summer, if the rule is summer, it is returning 15% or not. Okay, so what I'm going to do, guys, here to write that test, let us start with test method. Okay, and then we can say public void return, and in this we are saying that 15% return 15%, okay, for summer. So this is your test name. Discount calculator should return 15% for the summer rule, right? And now I'll go here and say var result equal to, we already have the discount calculator dot calculate discount, and in this we need to pass amount and the rule. So here I'll go and say summer. You see that I'm passing amount and the rule. Here my rule is summer, so I'll take that and passing that over here. Great. Now we know that if the amount is 100, then it should be 50. It should return us 15. I'll go ahead and say assert are equal. The object expected is 15, and this is the actual result. So here we can go ahead and write a test to test a particular rule, and here it will succeeded. I can go to test Windows and then text explorer. Here you see that I have 15% for summer test in my test explorer. Let us go ahead and take that text explorer from there, that test, and say run selected test, and this is good. That test passed. Great, and which is expected. Now assume that a new rule has been introduced in the system, and in the same way a new so we are asserting here that what should be the result if you call calculate discount with the rule summer and amount 100. You know that the return would be 15, right? So here we are testing that a particular rule has been tested successfully or not, right? So to test summer, what we have done here, we are making instance of discount calculator, okay, passing a amount, passing the rule, and this test is getting cleared, right? We know that 15 would be returned. In the same way, we can go ahead and write a test for winter as well. We'll say, so for winter, we are saying 10%. Here we'll say that return 10 for winter. And then here we can say calculate discount, winter pass, and here we know that expected result is 10, right? So again, if we go ahead and compile the project and say rebuild, we have one more test, 10% for winter, run selected test, and that test is passed also. So we have two rules and both rules are getting tested here successfully. Now assume that we have one more rule we are introducing in the system, and that rule is here, which is saying that return 5 for Independence Day discount. I'm calling it ID discount. Here we are having 100 IDs to return 5. Of course, right now if we go and run the program and try to test a 5 for discount, we are going to get the red because we have not implemented any rule for ID. Okay, we don't have any rule in our system for ID. So if I go ahead and run the selected test, we are going to get exception. And here you can read the exception in the bottom that we are expecting 5, however, actually 0. Now a new rule has been introduced in the system, and if we want to make this test green from the red, what we need to do, we need to go to discount calculator, and again we'll have to modify the existing code. See guys, what I'm doing here, I'm modifying the existing class. I'm modifying the existing class. It means I'm violating the OCP. I'm violating open close principle over here. I can go here and say that, hey, rule is ID. I can go ahead, modify this ID over here, and then say amount is 5% or something. Amount is 5%. So we can say 0.05. Now since we have implemented this, that is okay, but we are implementing it by modifying the existing class, which we don't want. Now again, let us go ahead and rebuild, and again if you go and run the selected test, you see that test got passed. So test got passed from green to from red to green, but we achieved that by modifying the existing class, which we don't want, and this is the problem. Right now, how to solve this problem, right now we have only 3 rules. We can go ahead and keep adding if else, and then we can keep we go here and say that uh, go and run all the tests here. We can do that and all tests should be run, but imagine that if you have 1,000 of rules, then you have to rerun all those 1,000 tests, which you may not want because you are adding only one rule in the system. So we should able to modify, we should able to extend the class, that discount calculator class, but we should not modify it the way we are doing it here. Okay, so how to do it? We can refactor this by, let us go ahead here. Okay, let me go ahead and add a new class. I'll call this class as let us say OCP. Implemented, I'm just putting everything inside that class, so don't worry about that. Okay, now inside this, what you can do, you can create an interface called, let us say, public interface iDiscount calculate. Okay, so here you have the interface called iDiscount calculate, and that interface has a rule and calculate, which is the function which is going to calculate the rule. Then what you need to do, you need to create different classes for different rules. Here you can go and say public class summer discount calculator, iDiscount calculate. It will implement this iDiscount calculate, and here we are saying that if a rule is summer, then it will return true, then calculate as 15%. So simple. Step 1, go ahead and create an interface. Step 2, for each rule you are going to create a new class. Great. So this is for the summer. In the same way, we can go ahead here and we can write a class for winter, and the winter class would look like This winter discount calculator, again implementing I discount calculate rule winter equals rule name calculate. Okay, so here we are public class summer calculator interface. So if you have new rule coming to the system, all you need to do to go ahead and create a new class and implement this particular interface. Great. Once that is done, what we need to do, we need to go to the discount calculator class, which is here, which we have created, this discount calculator class. In that we have double discounted value. uh, what we'll do here, we'll create a list of I discount calculate. Okay, and we can call them as, let us say, discount services. Okay, now instead of this public double calculator discount, let us go ahead and comment this particular code. Okay, and what we are going to do, we are going to in the constructor of the discount calculator, what we'll do, we will add all these discount classes which into the discount service which we have just created. So we are adding summer discount calculator, we are adding winter discount calculator. So when the discount calculator class is ready, it has the object of summer discount calculator and winter discount calculator, and then we can go ahead and write a class to calculate a discount, the same method which we had here, public calculate discount. So we'll go here and say public calculate discount amount and string rule, and then we can say this discounted this discount value equal to discount service dot find a rule, and then calculate the amount and then return the discount value. So pretty simple. I'm going to explain you what I have done. Let me first go and rebuild it, and we have refactored that to OCP. Okay, so what I have done here, I have created a interface which contains rule and calculate methods. Then if I have created separate classes for separate rules. Here I have summer discount calculator for I discount calculator, then I have inter discount calculate. Great. And then in the discount calculator class, what I'm doing here inside the constructor, I'm adding all those discount classes and then calculating this. Now if we go ahead and run the test again, here we are, run the test again. Let's go ahead and rebuild it. Okay, so if we go and run for 15% for summer, the test is getting passed. I can go and run for 10% for winter, test will be passed. So I'll have to say that what I have given there for the winter. So for winter, we have given 20, actually it should be 10. Great, so for winter, we have given 10. Now we go and run this, so this test will be passed. Now we have 5 for the ID discount, the same problem. Now if I go ahead and run this test is going to fail because we don't have any rule set for Independence Day discount. Now how we can do that? Previously, we saw that we modified the if else in the existing class. Right now, we don't need to do that. We won't have to modify any class. We'll just go here and add a new class called, let us say, ID discount calculator. Okay. So we are adding a new class. We are not modifying any class, right? And here we can say ID. Okay, and then this percentage is, let us say, 0.5. Great, we have added this here, a new class. Then we'll go to discount calculator here, discount calculator.cs. Then we need to add in the service. Of course, you can refactor this also using dependency injection, and then we can say ID discount calculator. Once that is added, now if I go rebuild this and run this test, okay, so let us go ahead and say ID. Okay, it is capital. Actually we gave the capital value over there for the id. Okay, now let us again go ahead and rebuild just some string missing there, and then run selected test. You see that that test is getting passed. So I just saw you that if we follow OCP principle, we don't have to modify the existing class. We can add a rule without affecting another rules, and the steps are create an interface, create a class, implementing that interface. That's it. So this is all about OCP principle. Great. Now let us move to next, that is LSP. LSP stands for Liskov substitution principle, and what it says, object of a derived class should able to replace object of the base class without bringing any error in the system or modifying the behavior of the base class. Okay, so if S is subset of T, then object of T could be replaced by object of S without impacting the program and bringing any error in the system. Okay guys, so what's happening here is that, let us say you have a parent class and you have a child class. Then the parent class should be replaceable by the child class without bringing any error in the system. That is LSP. So class should be designed in such a way that if you go to your inheritance definition, if you go to your classical inheritance definition, you say that it is a relationship. So if you have a rectangle class and a square class inheriting the rectangular class, we'll say square is a rectangle. All right. LS principle says instead of is a, we'll say is substitute for. So we'll say if we have a rectangle class and then we have a square class, and a square class is inheriting the rectangle class, then we'll say a square class is substitute for the rectangle. This is LSP, or Liskov substitution principle. Now let us see this in the demo, what is the problem and how we can work with this. So great, I will go again very quickly here. So here I am going to add one more class. I'll say ls. I'm calling that ls. Okay. Public class ls or anything. Now inside this class, let us say I have a rectangle. I have a rectangle class which has integer height and integer width, and then I have a square class which is inheriting that rectangle class. Okay guys, very simple. I have two classes. One is rectangle class, which you see here. And then I have a square class which is inheriting the rectangle class. Okay, since height and width of the rectangle class is virtual, a square class can override them and give them their own meaning. Right, so we have two classes here, and classical inheritance says that a square is a rectangle. Okay, LSP says a square can substitute the rectangle. Let us see what is the problem here. Okay, now we have one more. We are going here and let us say adding one more class here called area calculator. So guys, what I'll do today, we'll complete till the LSP, and in the next we will continue with dependency inversion principle and interface segregation principle. Okay, so let us complete till up to LSP, Liskov substitution principle today. So here you see that we have a class called area calculator. In this class, I have overloaded method to calculate area. We pass rectangle, it gives me return r dot height and r dot width. Then I pass a square, it gives me s dot height and s dot height. A square is like, a square of the sides. That is how it calculate the area. That is simple geometry. So this is simple class. I repeat guys, I'm trying to go slow. I have a rectangle class and then I have a square class. A square class is inheriting rectangle class and giving its own meaning to the width and height. Since in a square, height and width are of the equal size, we are overriding that and If user is passing height, we are saying height and width both are same. If user is passing width, we are saying height and width both are same. Now we have another class to calculate the area of rectangle and a square. That class name is area calculator. When we pass rectangle, it gives us height into width multiplication. And when we pass a square, it gives us side square as the area. Very simple scenario. Now let us go and try to test this calculator area. Okay, how we can do that. So to test this calculator area, what I'm going to do, I'm going to write one more class here quickly, and I'll call that as test area to return. Test area should return, and quickly what we are going to do is that let us go ahead here and add this namespace. So test area should return using namespace. Then we'll make this class as a public class and then make this guy as test class. Great. So we have this. Next, what we are going to do, that we have a test method here 6 for 2 into 3 rectangle. So if we pass 2 and 3 to a rectangle, we should get the area 6. It's very simple. Area calculator that calculate area, and in the area calculator what I have done, those are the static methods, so we can call them directly. So this is pretty simple test, right? I will go here and build it and try to run this test. So run selected test, and this test is getting passed. It's all right, no problem. Next, go and write one more test here. So we should get 9 if we pass a 3 to 3 square, and this test will be passed as well. So I'll go here and say rebuild. Great. And then again say 9 for 9, run selected test, and this test is getting passed as well. So this is expected when we are creating instance of a square, we are passing a square. When we are creating instance of rectangle, we are passing rectangle, and it is working fine. Now the catch is when we try to substitute a square with a rectangle, and for that I have written one more test, and that test is here. Now you see that what I'm doing in this test, I'm saying I'm creating line number 32 here, that I'm saying rectangle, new rectangle equal to new square. C# allows us to do that, right? We can create a parent p equal to new child, and then I'm saying new rectangle dot height equal to 4, new rectangle dot width equal to 6, right? Since I'm creating object of a rectangle, I'm calling calculate area function and then passing this new rectangle over here. What I'm expecting that I should get the output 24, right? But I'll be getting the output 36 because a square does not substitute the rectangle. Now let us go ahead and try to run this code here. And if you go and run the selected test, here you see that we are getting the error that actually is 36 and we were expecting 24. And this is the problem, that a square is not able to substitute the rectangle. Then how we can do that? So even though it's the inheritance is there, square is a rectangle, it is not substituted, it does not substitute the rectangle object, so it is violating the Liskov substitution principle. Now how we can write the code such that it does not violate that? So we can do it in two ways. One, by using by having no inheritance, and for that what I'm going to do, I'm going to create a first abstract class here, and I'll call that abstract class as shape. Okay. Then after, what I'm going to do in the rectangle class. Okay. So this rectangle class which I have now is going to inherit the shape class. It has its height, it has its width, and then it has its area. Okay, so this is how your rectangle class is. Simple. Then I have a square class which is also going to inherit the shape class. So here I'm going and I have a square class which is also inheriting the shape class, and then it has a property called sides, and the area is side square. Great. Now what I'm going to do, I am going to write the test again. Okay, so what I'm going to do, that I have already written the test here. For this, I'll say that new rectangle, then area cal. So instead of area calculator, I'll say here that give me my rectangle dot my rectangle dot area, and here we can pass the uh, we don't need to pass anything, it will take directly from height and width. So this test should pass. In the same way for the square, what we'll do, we'll say new square, and this is actually sides equal to 3, and then we can say my square dot area, which we have already done here. Okay, so my square dot area, and then asserts are equal 9 result. So this is good. Okay, great. So first let us go ahead and just try to comment this code and run it again. So we are going to comment this code here. We don't need that. Okay, square calculate area. We don't need this area calculator, so let's comment that also. And now again, let us go ahead and rebuild this code. Everything is fine. Now if I go and run this 943 square, you see that test is getting passed, and 6423 rectangle, that test is also getting passed. But we have one more test in which we want to replace them, and that test I'm writing here. Okay, so I have a test method 24 for 4:6 rectangle and 9 for 3:3 square. Here I'm saying var shapes equal to new list shape, new rectangle height, new square sides, and var area is equal to new list. And then what I'm doing, I'm iterating through the shapes. Okay, and then adding the area, and then we can easily test. In the same way, if tomorrow a new shape is coming, let us say triangle, what all you need to do, let us first go ahead and run this test to see that it's working fine. Here we go. So this test is working fine. If tomorrow a new shape is coming, what all you need to do, you need to just replace that, inherit that test from the shape class, which we are doing here, okay? And you need to add that if condition over here. Now again, you say that if we need to add if condition here, actually we are violating the open close principle, because we are modifying the existing class. Is there any way we can get rid of this? And yes, we can do that. What we can do, we can quickly go to shape class here, and in shape class we'll add a public abstract integer area, and then the rectangle class will override the area. In the same way, a square class should also override the area. Now if you go to the test back, in the test, now we can say that hey, shapes newly side where area is new integer. Okay, and you just need to, in the shape, say that areas dot add. Now you don't have to do any if condition that what kind of area that is, because that area is function has been moved to the base class, and every class is overriding them. Now again, if you go ahead and run this quickly, and if I go and run the selected test, you see that test is getting passed. So we are able to, now we should able to add any new shape in the system just by inheriting the shape class, right? And that particular shape will have its own area method which will override this area, and we should able to test that over here. So here we are not extending the class, but we are not modifying the existing class. So this is how you can implement Liskov substitution principle. I understand, guys, that today, due to technical glitch, we started a bit late. We started around 20 minutes late. So for sure, we will complete this, and next webinar when Infragistic will do in India time zone, we will do the solid once again, and start and focus on dependency inversion principle and the uh, mm, interface segregation principle. So ISP says that you should have a role-based interfaces. You should not have a very big interface. You should have small interfaces completing doing a particular a task. So a wide fat interface, create role-based interface. What is this? Is ISP. Then you have a dependency inversion principle, which says that high-level models should not depend on the low-level models, but both should depend on the abstraction. So today we are. I'm sorry that we are not able to do demo on these two, but in next webinar definitely we are going to cover them. I hope you find today webinar useful. I'm going to answer your question. Uh, you will have this recording of this webinar available later on Infragistic blog. And at the same time, guys, you can download a free trial of Infragistic products on infragistics.com. And if you have any query related to Infragistic, uh, mm, uh, please send an email to sales_india@infragistics.com. And guys, thank you so much once again for joining today webinar. I hope it is I hope it is useful to you. I'll see that how many questions I can take now. I'll try to answer as many questions as possible now, and I'll try to, in the follow-up blog, we'll try to answer those questions. Uh, Guys, so thank you so much. I'm going to stop the recording once again. Thank you so much. I hope this webinar is useful to you. Thank you, guys. We appreciate your participation.